All right, now we're going to look at how you can do integration by parts when it's a definite integral. So when you're doing a definite integral, whatever your limits are here, you want to do the integration by parts formula. The integral part of that stays the same, the limits stay the same. On the part that doesn't have the integral, you then evaluate it at both A and B on the part, the UV part of that. So let's try one of those. We want to integrate by parts integrate this using integration by parts with this definite integral. So first off, we want to figure out what's our u and v. We got a polynomial function here, and we got an exponential function here. Polynomials come higher on the list, so that would be our choice for u. Seeing that this has an x squared, it looks like we're going to have to do integration by parts twice. There is a little trick you can use when you have to do repeated integration by parts, and one of them is a polynomial like this, and that's the little table method. I'm going to show you that as well today too. So you want to have your u and your dv choices, and then on the left side you're going to write your polynomial down, and you're going to keep taking derivatives of that side till you can't do it anymore. So first derivative of this would be 2x, next derivative of that would be 2, next derivative of that would be 0, and then all the derivatives after that continue to be 0. On the other side, our choice for dv here is e to the negative x. So on this side, we have to keep doing antiderivatives of all these, because that's what you do when you have the dv part. This one, you got to be a little bit careful here. Antiderivative with that negative in, almost like a substitution here. Antiderivative of this is going to be same one always with exponentials, but in order to for this one to be positive, if we would take the derivative of this one, we would need that extra negative there, because it's kind of chain rule with that e to the negative x. What would be antiderivative of this? It would be kind of two negatives here, so it'd be back to positive e to the negative x. What would be antiderivative of that? It just is going to keep bouncing back and forth here with our antiderivatives. And we can stop there since we got to 0 over here. The remaining ones are going to be just 0. All right, so this table method now with integration by parts, what you're going to do here, this is our first u right here. This would actually end up being our first v, so we want those two multiplied together. So when you're doing this table method, you got to draw lines diagonally now, because those are the ones that need to get multiplied together. So we want to go diagonally like this. And then as you're going through, you got to alternate back and forth between positive and negative because of this negative in integration by parts. So our uv is right here. That should be positive. The next part of this, so because of this negative sign, should turn negative. If you were to do it again, it would be a negative of a negative, so back to positive. So you got to alternate, no matter how many of those arrows, you got to start with plus, alternate back and forth with positive, negative, and so on. All right, so what this is going to turn into now using integration by parts would be our first two things multiplied together here. So it'd be x squared plus 1 times this negative e to the negative x with a positive sign being multiplied in there too, which doesn't really change anything. So it'd just be this times a negative e to the negative x. All right, now we go to the next thing. So the next thing would be multiplying 2x with e to the negative x, but we need another negative in there, so it'd be plus 2x times a negative e to the negative x, so there's going to be a negative in there. Where you put that negative is up to you. Since we know it's going to be negative, I'm just going to put the negative here, so it's going to be e to the negative x. All right, now we want to multiply these next ones, so 2 times the positive times negative 2e to the negative x, that's just going to be positive here, 2e to the negative x. And since that's the last one, we're done here. So that would be all the antiderivatives of all these. So now what we have to do is evaluate all this at our upper and lower limit. So all this needs to now get evaluated at 1 and 0. So when you do this table method, you already find all these antiderivatives out. It's just now evaluating this. If it wasn't, you just put your plus c and you'd be done. Before I go through and do this one, we could maybe, I think it's probably good if we just put it in there. All right, so let's see what we get when we plug a 1 to in all this, and then what we get when we plug in 0. So if we plugged in 1, 1 squared is 1 plus 1, so this is going to be 2. If we plugged 1 in for the exponential one, it's going to be a negative e to the negative 1. Minus, if we plug 1 in here, it's going to be 2. If we plug 1 in, it's going to be e to the negative 1. Plugging 1 in this next one, we got a 2 again, and it's going to be a negative e to the negative 1. All right, so we get all that minus what we get when we plug in 0. If we plug in 0 here, we're going to get 0 squared. 0 plus 1 would be 1, though. E to the 0, anything to 0 power is 1. Minus 2 times 0, 0. 0 times anything is just going to be 0, so that's 0. In the next one, we got plus 2. E to the 0 power is going to be e to the 0 power is going to be 1, but there is that negative in front, so it's going to be negative. And in fact, this other one, this one here should be negative as well if we got that negative in front of it. All right, so now it's just seeing what this equals here. See if we can simplify this at all. This would be like negative 2. I'm going to move that e down to the denominator to make the exponent positive. Minus, I'm going to do the same thing here. And this next one's also negative, so I'm going to also do it here. So we get that minus, let's see what this other one, here we got a negative 1, minus 0 is gone, minus a 2. So putting this together, now these are, it is a common denominator here. So if we minus all these, minus 2 minus 2 minus 2 would be the same as negative 6 over e. And then this evaluates to negative 3, but it's minus a negative 3, so it'd be like plus 3. So it looks like that would be the final solution to this one. All right, let's take a look at another one here. Use integration by parts to solve here. So first off, I'm not going to be able to do a substitution with this inverse trig one there. So that looks to be our u here. So inverse cosine, or sometimes I might say arc cosine of x. That means our dv is the rest of this stuff. So that would be just dx here. Antiderivative of that would just be x. On the other side, we got to do derivative. This is one of those derivatives that you should know from the inverse trig unit, which is negative 1 over the square root of 1 minus x squared. If that would be a derivative that you don't remember how you can solve out or figure out that derivative if you have inverse cosine would be to move that cosine to the other side and do implicit differentiation on it. So derivative of the right side would be 1. Derivative of cosine y would be negative sine y, but it's a y1, so you'd include derivative dy dx. To solve for that, we divide, so our derivative dy dx here would be negative 1 over sine y. And then to figure out what the sine y equals, think about the triangle that goes with this here. So if our angle is y and we're doing cosine, remember cosine is adjacent over hypotenuse here. So if our adjacent over hypotenuse is equal to x, that's going to be like our adjacent side is x and our hypotenuse is 1 because x over 1 would be x. Then what you'd have to figure out is what is this side so we can get the sine of that. You can use Pythagorean Theorem to do that. A squared plus b squared equals c squared. Here this means we got x squared plus b squared equals 1 squared. That means b squared, if we subtract, is 1 minus x squared, and square rooting would give us square root of 1 minus x squared. So that would be what this side is here, is square root 1 minus x squared. And so now if you substitute in, sine would be the opposite side here over the hypotenuse, so it'd be this over 1, which would just be that square root, and then substituting in, you see we do get that same thing that we put for the derivative on the other side. All right, so we got our things here. Let's substitute that in now with integration by parts. So we'd have u v, so it'd be cosine inverse of x times v minus the integral of v du here, so it'd be times negative 1 over this x here. Actually, I forgot the dx when I was doing that. And then this one's a definite integral, so we want to keep those limits in here, so 1/2 and 0. That also means this side we need to be evaluating at both 1/2 and 0. All right, so now let's see what we can come up with here for this one. A couple things here. Make sure on this one, don't multiply these two x's together and put x squared because it's inverse cosine of that. So we'd have to write that as x cosine inverse x evaluated at 1/2 and 0. We'll get to that. On this other one, I see both of these are negative here. I'm going to write that as a positive. And we get this integral from 1/2 to 0 to 1/2 of x over square root 1 minus x squared dx. All right, eventually we are going to have to evaluate that integral, so how are we going to do that? They're both polynomials, so hopefully with a substitution now we could do that one. So let's try doing a substitution on that. Let's put u equal to what's under that square root. Derivative of that then being negative 2x dx. And it looks like we do have that x dx over here. So let's move the negative 1/2 to the other side. So x dx would be equal to, divide that, negative 1/2 du. So now we should be able to make our substitutions on this one. I'm not going to evaluate this yet. We'll get to that in the same step here. So if we make our substitutions, this is going to turn into square root of u now. The x dx turns into negative 1/2 du. The negative 1/2 here, I'm going to put out in front of this. All right, and then when we're doing this here, we've changed our integral, so we should also change our limits on that. So if we go back and figure that out, u at 0, that's going to turn into 1. And if we put 1/2 in there, we got 1 minus 1/2 squared. That's going to be 1/4, or our new limit here then becomes 3/4. So we want to change these to both 1 and 3/4 here. All right, so now let's see if we can do this antiderivative here. An easier way to think about this one looks like it's going to be to think of this as u to the negative 1/2 by moving that up to the numerator and thinking of square root as 1/2. So what's the antiderivative of that? We have to add 1 to the power, which would be positive 1/2, and put the reciprocal in front. Reciprocal of 1/2 would be 2. And we still need to carry through here our negative 1/2. So now we should be able to evaluate and solve this one. Now, had this been a calculator problem, of course you can use your calculator, but this is one they could maybe expect you to do without a calculator. Now we got to plug in our values here and solve this one out. One thing, this should simplify to just 1 here. So when we're doing that, I'm going to think of that as just 1. So here we got, we're going to plug in half first. So we got half the cosine inverse of 1/2, that value, minus 0 times cosine inverse of 0. There, over here we're going to have minus, and then we got, I'm going to think of u to the 1/2 as square root u, so we're going to have square root of 3/4 minus square root 1 here. All right, so now let's evaluate these and see what we get. The more of this right side looks pretty easy here. This is going to be same as square root of 3 over square root of 4. Square root of 1 is just 1. That's going to give us square root of 3 over 2 minus 1. And since they're both, you got this minus sign out front, eventually we're going to have to distribute that to both of these here. So this is going to end up being minus square root of 3 over 2 plus 1. All right, now let's look at this other one. This is a little bit, or one of these at least is a little bit harder. This one's going to be easy because if we got 0 times anything, we know that's just going to end up being 0. This one a little bit harder though. How do we do cosine inverse of 1/2? So again, you got to think trig here. So if we have our unit circle, which angle is going to give us a value of 1/2? Well, if we have one of these triangles here, we got cosine. So remember, cosine is your x value, sine is your y value on the unit circle. And so we're looking for what's the x value. We want that to be 1/2. Remember, hypotenuse is always 1. That's going to occur when this is a 60-degree angle because this side should then be 1/2 of the hypotenuse, which would be 1/2, and this side would be square root of 3 over 2. So we wanna use this with a 60-degree angle. So if we know that, that means cosine inverse of 1/2 then should equal 60 degrees. That would be the angle that produces that. The problem here, though, we don't want it in degrees. We want to answer in radians. So what is 60 degrees in radians? 60 degrees would be the same as 1 or pi. Our conversion here is to multiply by pi over 180. So we want to multiply this by pi over 180 degrees. That's going to be 60 pi over 180. We can simplify that. If we divide them both by 10, it's 6 over 18. 6 goes into 18 3 times, so this is going to be the same as pi over 3. So pi over 3 is what inverse cosine of 1/2 should give us. So going back to our problem now, when we want to evaluate this. And this is something like on an AP test you should be able to do without a calculator. They could expect you to do that. This would end up being 1/2 of pi over 3. Because cosine, inverse cosine of 1/2 is pi over 3. All right, so to finish simplifying that, multiply, so this would be pi over 6 minus all that stuff. So getting down to our answer then, we get pi over 6 minus all that. So that would be the exact answer of this one. If it's a free response, that answer would give you full credit. Had this been a multiple choice one, there is a chance that your answer might have a common denominator. So just be able to see that if this is your answer, that this would also be the same as getting a common denominator of 6 throughout this. Here we'd have to multiply by 3 over 3 to get a common denominator. This last one would be the same as 6 over 6. So if you put it together, you could also see the answer written as this pi minus 3 square roots of 3 plus 6 over 6. So you could also maybe see the answer written as that if it's a multiple choice question and you needed to match it up.